In this unit, we're going to talk about matrix operations, how to solve equations using matrix. And then at the top of the page, it just gives you a little introduction about what they really are and where you can use them. And a matrix is an organized rectangular array of numbers, and a determinant is a value associated with each square matrix. So the earliest known example of numbers being placed in an array in order to aid analysis is clay tablets from Babylon of the 4th century BC. So matrices are tools for organizing and storing information. Management of information such as cost of materials, time to produce each item, available inventory by month, needed inventory, and so forth provide material to create a variety of matrices. Develop definitions and basic matrix operations. Dimensions and dimension labels are used to provide rationale for addition and multiplication procedures. So emphasis is placed on interpreting entries as matrices are written, added, multiplied, and transposed. So properties of real numbers are examined to determine which properties are true in matrix operations. Determinants are used to find areas of triangles and test for collinear points. Systems of equations, which is the big one that we're going to look at, are written as matrix equations, and inverses of coefficient matrices are used to solve the systems. So we will work with the basic operations of these and how they're used to look at data. But the big one is that they help you guys to solve systems of equations, not with 2 variables, but 3 variables, which is something you guys may not have done before. So we identify matrices or label them based off their rows and columns. So, and that is the order that we need to label them at. So it's the number of rows by the number of columns. So just remember, rows go from left to right. So this would be a row here. And then your columns are your vertical numbers. So like 1, 6, and 2 would be a column. So that first matrix, it's a square matrix, but it would be 3 rows by 3 columns. Your second one is 1, 2, 3 rows by 2 columns. So 3 by 2 matrix. And your last one is 1 row by 1, 2, 3, 4 columns. So 1 by 4 matrices. So those are your dimensions. That's how we label our matrices. So if you are given 2 different matrices, the 2 matrices are equal if and only if all corresponding entries are equal. So this means if you have a 4 by 5 matrix and another 4 by 5 matrix, each value in each individual spot has to be the same in both matrices. That's what corresponding entries mean. Now there are some special kinds of matrices. The first one is a row matrix, and we have a column matrix. Now they're all pretty self-explanatory, but a row matrix is a matrix with only 1 row. And remember, just don't get your rows and columns confused. A matrix with only 1 row, so that would look like, and we don't put commas between our data entries. We just make sure that we leave enough space so that we can tell that they are separate entries. So like if you have a number 23, you would want to make sure the 2 and 3 are together to see that it's a single value. Space, then put your next value. Column matrix, again, self-explanatory, but a matrix with only 1 column. And remember, columns are up and down, so that could be like 3, 0, 2. I can see if I can write that smaller. And we could make it even 2 by 1. But only has a single column. So a square matrix, you guys know what a square is, going back from geometry, but it's 4 equal sides, 4 right angles. But a square matrix is a matrix with the same number of rows and columns. So with equal rows and columns. So something like this, a 2 by 2. You could even have a 1 by 1. So with a single entry, it's still 1 by 1. Row and columns are equal. It just happens to be a single entry. And then last but not least, a zero matrix is a matrix with only zeros as entries. So it doesn't really matter what size it is. It's just you cannot have a single number other than 0 as one of your entries. That's it. So instead of calling it a 2 by 2 or a 3 by 3 or a 1 by 7, we could call them a row matrix, a column matrix, or a square matrix, or a zero matrix. We'll still use the dimensions, but if you hear those terms, you should be able to recognize and understand what you should be seeing.